Techniczny Język Angielski z blogiem inżynierjakości.pl. Lekcja numer 6. Assembly Line – How it works. Zapraszam do wysłuchania specjalnie przygotowanego tekstu, czyta pani lektor, a po tekście zapraszam do wysłuchania 35 wyselekcjonowanych słówek. Powodzenia!
Assembly line. An assembly line is a manufacturing process, often called a progressive assembly, in which parts, usually interchangeable parts, are added as the semi-finished assembly moves from workstation to workstation, where the parts are added in sequence until the final assembly is produced. By mechanically moving the parts to the assembly work and moving the semi-finished assembly from workstation to workstation, a finished product can be assembled faster and with less labor than by having workers carry parts to a stationary piece for assembly. Assembly lines are common methods of assembling complex items such as automobiles and other transportation equipment, household appliances, and electronic goods. Concepts. Assembly lines are designed for the sequential organization of workers, tools or machines and parts. The motion of workers is minimized to the extent possible. All parts or assemblies are handled either by conveyors or motorized vehicles such as forklifts or gravity with no manual tracking. Heavy lifting is done by machines such as overhead cranes or forklifts. Each worker typically performs one simple operation. According to Henry Ford, the principles of assembly are these. 1. Place the tools and the men in the sequence of the operation so that each component part shall travel the least possible distance while in the process of finishing. 2. Use work slides or some other form of carrier so that when a workman completes his operation, he drops the part always in the same place, which place must always be the most convenient place to his hand, and if is possible, have gravity carry the part to the next workman for his own. 3. Use sliding assembling lines by which the parts to be assembled are delivered at convenient distances. Simple example. Consider the assembly of a car. Assume that certain steps in the assembly line are to install the engine, install the hood, and install the wheels. In that order, with arbitrary interstitial steps. Only one of these steps can be done at a time. In traditional production, only one car would be assembled at a time. If engine installation takes 20 minutes, hood installation takes 5 minutes, and wheels installation takes 10 minutes, then a car can be produced every 35 minutes. In an assembly line, car assembly is split between several stations, all working simultaneously. When one station is finished with a car, it passes it to the next. By having 3 stations, a total of 3 different cars can be operated on at the same time, each one at a different stage of its assembly. After finishing its work on the first car, the engine installation crew can begin working on the second car. While the engine installation crew works on the second car, the first car can be moved to the hood station and fitted with a hood, then to the wheels station and be fitted with wheels. After the engine has been installed on the second car moves to the hood assembly. At the same time, the third car moves to the engine assembly. When the third car's engine has been mounted, it then can be moved to the hood station. Meanwhile, subsequent cars, if any, can be moved to the engine installation. Assuming no loss of time when moving a car from one station to another, the longest stage on the assembly line determines the throughput, 20 minutes for the engine installation. So a car can be produced every 20 minutes, once the first car taking 35 minutes has been produced. History. According to Dom, the implementation of mass production of an automobile via an assembly line may be credited to Ransom Olds, who used it to build the first mass-produced automobile, the Oldsmobile Curved Dash. Olds patented the assembly line concept, which he put to work in his Olds Motor Vehicle Company factory in 1901. At Ford Motor Company, the assembly line was introduced by William Parkland upon his return from visiting Swift & Company's slaughterhouse in Chicago and viewing what was referred to as the disassembly line, where carcasses were butchered as they moved along a conveyor. The efficiency of one person removing the same piece over and over without himself moving caught his attention. He reported the idea to Peter E. Martin, soon to be the head of Ford production, who was doubtful at the time but encouraged him to proceed. Others at Ford have claimed to have put the idea forth to Henry Ford, but Parkland's slaughterhouse revelation is well documented in the archives at the Henry Ford Museum and elsewhere, making him an important contributor to the modern automated assembly line concept. Ford was appreciative, having visited the highly automated 40-acre Sears mail order handling facility around 1906. At Ford, the process was an evolution by trial and error of a team consisting primarily of Peter E. Martin, the factory superintendent, Charles E. Sorensen, Martin's assistants, Clarence W. Avery, C. Harold Wills, draftsman and toolmaker, Charles Ebender, and Joseph Gallamb. Some of the groundwork for such development had recently been laid by the intelligent layout of machine tool placement that Walter Flanders had been doing at Ford up to 1908. The moving assembly line was developed for the Ford Model T and began operation on October 7, 1913 at the Highland Park Ford plant and continued to evolve after that using time and motion study. The assembly line driven by conveyor belts reduced production time for a Model T to just 93 minutes by dividing the process into 45 steps. Producing cars quicker than paint of the day could dry, it had an immense influence on the world. In 1922, Ford, through his ghostwriter Crowther, said of his 1913 assembly line, "I believe that this was the first moving line ever installed. The idea came in a general way from the overhead trolley that the Chicago packers use in dressing beef." Charles E. Sorensen, in his 1956 memoir, My 40 Years with Ford, presented a different version of development that was not so much about individual inventor as a gradual, logical development of industrial engineering. What was worked out at Ford was the practice of moving the work from one worker to another until it became a complete unit, then arranging the flow of these units at the right time and the right place to a moving final assembly line from which came a finished product. Regardless of earlier uses of some of these principles, the direct line of succession of mass production and its intensification into automation stems directly from what we worked out at Ford Motor Company between 1908 and 1913. Henry Ford is generally regarded as the father of mass production. He was not. He was the sponsor of it. As a result of these developments in method, Ford's cars came off the line in 3-minute intervals or 6 feet per minute. This was much faster than previous methods, increasing production by 8 to 1, requiring 12.5 man-hours before, 1 hour 33 minutes after, while using less manpower. It was so successful, paint became a bottleneck. Only Japan Black would dry fast enough, forcing the company to drop the variety of colors available before 1914 until fast-drying Duco lacquer was developed in 1926. The assembly line techniques was an integral part of the diffusion of the automobile into American society. Decreased costs of production allowed the cost of the Model T to fall within the budget of the American middle class. In 1908, the price of a Model T was around $825, and by 1912 it had decreased to around $575. This price reduction is comparable to a reduction from $15,000 to $10,000 in dollar terms for the year 2000. In 1914, an assembly line worker could buy a Model T with 4 months' pay. Ford's complex safety procedures, especially assigning each worker to a specific location instead of allowing them to roam about, dramatically reduced the rate of injury. The combination of high wages and high efficiency is called Fordism and was copied by most major industries. The efficiency gains from the assembly line also coincided with the takeoff of the United States. The assembly line forced workers to work at a certain pace with very repetitive motions, which led to more output per worker, while other countries were using less productive methods. In the automotive industry, its success was dominating and quickly spread worldwide. Ford France and Ford Britain in 1911, Ford Denmark 1923, Ford Germany and Ford Japan 1925. In 1919, Vulcan, Southport, Lancashire, was the first native European manufacturer to adopt it. Soon, companies had to have assembly lines or risk going broke by not being able to compete. By 1930, 200 companies which didn't had disappeared. The massive demand for military hardware in World War II promoted assembly line techniques in shipbuilding and aircraft production. Thousands of Liberty ships were built, making extensive use of prefabrication, enabling ship assembly to be completed in weeks or even days. After having produced fewer than 3,000 planes for the United States military in 1939, American aircraft manufacturers built over 300,000 planes in World War II. Vultee pioneered the use of the powered assembly line for aircraft manufacturing. Other companies quickly followed. As William S. Knudsen, having worked at Ford, GM, and the National Defense Advisory Commission, observed, "We won because we smothered the enemy in an avalanche of production, the like of which we had never seen nor dreamed possible." Interchangeable parts. The concept of interchangeability was crucial to the production of the assembly line at the beginning of the 20th century and has become an important element of some modern manufacturing, but is missing from other important industries. Interchangeable parts are parts, components, that are for practical purposes identical. They are made to specifications that ensure that they are so nearly identical that they will fit into any assembly of the same type. One such part can freely replace another without any custom fitting, such as filling. This interchangeability allows easy assembly of new devices and easy repair of existing devices, while minimalizing both the time and skill required of the person doing the assembly or repair. Interchangeability of parts was achieved by combining a number of innovations and improvements in machining operations and the innovation of several machine tools, such as the slide rest lathe, screw-cutting lathe, thread lathe, milling machine, and metal planer. Additional innovations include jigs for guiding the machine tools, fixtures for holding the workpiece in the proper position, and blocks and gauges to check the accuracy of the finished parts. Electrification allowed individual machine tools to be powered by electric motors, eliminating line shaft drives from steam engines or water power and allowing higher speeds, making modern large-scale manufacturing possible. Modern machine tools often have numerical control, NC, which evolved into CNC, computerized numeric control, when microprocessors become available. Methods for industrial production for interchangeable parts in the United States were first developed in the 19th century. The term American system of manufacturing was sometimes applied to them at the time in distinction from earlier methods. Within a few decades, such methods were in use in various countries, so American system is now a term of historical reference rather than current industrial nomenclature. Improved working conditions. In his 1922 autobiography, Henry Ford mentions several benefits of the assembly line, including: workers do no heavy lifting, no stooping or bending over, no special training required. There are jobs that almost anyone can do. Provided employment to immigrants. The gains in productivity allowed Ford to increase worker pay from $1.5 per day to $5 per day once employees reached 3 years of service on the assembly line. Ford continued on to reduce the hourly work week while continuously lowering the Model T price. These goals appear altruistic, however, it has been argued that they were implemented by Ford in order to reduce high employee turnover. When the assembly line was introduced in 1913, it was discovered that every time the company wanted to add 100 men to its factory personnel, it was necessary to hire 963, in order to counteract the natural distance the assembly line seems to have inspired. Sociological problems. Sociological work has explored the social alienation and boredom that many workers feel because of the repetition of doing the same specialized task all day long. One of capitalism's most famous critics, Karl Marx, expressed in his Entfremdung theory the belief that in order to achieve job satisfaction, workers need to see themselves in the objects they have created, that products should be mirrors in which workers see the reflected essential nature. Marx viewed labor as a chance for us to externalize facets of our personality. Marxists argue that specialization makes it very difficult for any worker to feel they may be contributing to the real needs of humanity. The repetitive nature of specialized tasks causes, they say, a feeling of disconnection between what a worker does all day, who they really are, and what they would ideally be able to contribute to society. Marx also argued that specialized jobs are insecure since the worker is expendable as soon as costs rise and technology can replace more expensive human labor. Since workers have to stand in the same place for hours and repeat the same motion hundreds of times per day, repetitive stress injuries are a possible pathology of occupational safety. Industrial noise also proved dangerous. When it was too high, workers were often prohibited from talking. Charles Piaget, a skilled worker at the LIP factory, recalled that beside being prohibited from speaking, the semi-skilled workers had only 25 centimeters in which to move. Industrial ergonomics later tried to minimize physical trauma.
Dziękuję za wysłuchanie tekstu. Teraz przejdźmy do 35 słówek.
Assembly line, linia montażowa. Manufacturing process, proces produkcyjny. Progressive assembly, montaż postępujący. Interchangeable parts, części wymienne. Workstation, stanowisko pracy. Less labor, mniej siły roboczej. Workers, pracownicy. Tools, narzędzia. Machines, maszyny. Parts, części. Conveyors transporter, linia transportowa. Forklifts, wózek widłowy. Gravity, grawitacja. Overhead cranes, żuraw, suwnica. Working simultaneously, pracować w tym samym czasie. Mass production, produkcja masowa. Modern automated assembly line concept, współczesny koncept zautomatyzowanej linii montażowej. Process evolution by trial and error. Ewolucja procesu następowała poprzez próby i błędy. Developing, rozwój. Time and motion study, badania ruchu i strat czasu. Dividing process into the steps, dzielić proces na kroki. Come off the assembly line, schodzić z linii montażowej. Manpower, siła robocza. Bottleneck, wąskie gardło, straty muda. Safety procedures, procedury bezpieczeństwa. Automotive industry, przemysł samochodowy. More output per workers, większa wydajność na pracownika. Military hardware, sprzęt wojskowy. Aircraft production, produkcja samolotów. Productivity, produktywność. Industrial noise, hałas przemysłowy. Repetitive stress injuries, kontuzje wynikające z powtarzalnych ruchów. Occupational safety, BHP. Skilled worker, wykwalifikowany pracownik. Ergonomics, ergonomia.
Dziękuję Ci za wysłuchanie tej lekcji. Zachęcam do nauki 35 słówek, przesłuchania nagrania jeszcze raz, wyłapania tych słówek, które były na samym końcu. Przede wszystkim życzę powodzenia w nauce i zapraszam do kolejnych lekcji Technicznego Języka Angielskiego z blogiem inżynierjakości.pl. Do usłyszenia.